So test automation, this is a continuation of the lecture after the demo. Again, the demo is a separate video. If you want to watch it, you're welcome to. Not a requirement for this class, but certainly has information that might be of value to you. Good testing is a creative process, but thorough testing is time-consuming and repetitive. Regression testing involves rerunning tests over and over again. If you have the right harness or rig, you can usually achieve this relatively easily after everything is set up. There's other things, which is continuous integration testing, things like that, which are out of scope for this class, but are things that are worth looking into. Test harness, additional test harness, or additional test classes are written to automate the testing. Object of the harness classes replace human interactivity. The idea is that if you've written your harnesses properly, they run and they do some of the testing that people are doing, and you get better feedback, faster feedback, and more reliable, consistent feedback because you're never relying on somebody to remember to do it properly. You let the computer do it the same way every time. This way it's either consistently right or consistently wrong, which is actually high value all by itself. Creativity and imagination is required to create these test classes. You need to make sure that you've thought through everything, that you've got good requirements, everything else. There's a concept called the traceability matrix. It's very helpful. It's where you actually compare the test case to the requirement to the design to make sure that everything's actually implemented consistently together. So this way you have a three-way blend. It's an old concept. It's been around for a while, and it's very helpful. Test classes must be kept up to date. In other words, adding functionality without updating the test case classes does not help. It just results in a useless test harness or test class. The biggest thing that I can tell you is that in my past I've established things called steps of doneness. In there it's, did you create your test cases? Did you implement your test scripts? Slightly different era. Did you create test data? Did you test it? Did you create design? Did you verify your requirements? We had 13 steps in total. I'd encourage you to do much the same. Developers classically just want to get the code done and out the door and move on to the next cool thing. And this is where you really want them to slow down and make sure that they've created good test classes and harnesses, and that you've actually done good code reviews and things like that. Test frameworks exist to support automation. Explore fuller automation through the online shop JUnit. We went through online shop earlier. We'll go through online shop JUnit separately. Intervention is only required if something goes wrong. So in other words, it tests most of the code and will tell you if something's wrong, and that's the only time you have to do something. That demo will be done outside of this, so we're going to keep going. JUnit. JUnit is a Java test framework. It is amazingly cool, has great stuff in it. It has test cases, test classes, assertions, and fixtures. These are all important concepts in JUnit. Spend the time, go through the book, get very familiar with these, because these are the fundamentals of JUnit, and a shop will save money in the long run if they implement this stuff properly. Prevention versus detection, we talked about this before. We can lessen the likelihood of errors if we use software engineering like encapsulations, etc. We can improve the chances of detection if we use good documentation and modularization like you're supposed to. And if your shop develops good detection skills, everyone wins. Now, things go wrong eventually. Even though they may have made it through a test harness, you now need to develop additional skills, such as a manual walkthrough, print statements, and debuggers. Modularization in interfaces consists of different modules. The interface between modules must be clearly specified. All right? So in other words, your contract or how they go between each other needs to be very clear and concise, well documented, well understood, because if you've done that, the likelihood of a successful integration later can be done. Two developers can work independently with what are called stub code until the actual code is ready. This is a key concept in development, but only works if your contracts or the interfaces are actually well defined. Each module does not need to know the implementation. In other words, if user controls calls into arithmetic logic, it doesn't need to know anything more than what it takes to get through this squiggly line. In other words, it needs to know the interface and nothing more. Logic can be hardware or software based, it's irrelevant. Could be GUI, could be anything. It doesn't matter as long as the interfaces are well understood. Return the value to be displayed. In this case, method headers as an interface. They're clearly written, easy to understand. You know exactly what they do. And if you're using JavaDoc, you'll have even better results. Debugging is an important skill. There is a demo in the debugger. I have posted online. We've covered it in a past lecture. If you haven't gone through it, go through it now. It is very helpful. There's more information about it, and if you set your breakpoints, you can quickly go through and find where mistakes are happening and different ideas. In this case, there's a project called Calculator Engine. I am not going to do a demo of this one because I've already gone through how to do debugging or how to debug before. Manual walkthroughs, relatively underused. So in other words, you take a printout of the code and you walk through it line by line, or you walk through it line by line with a notepad next to you. It is a technique that I've used. People don't appreciate how good it is because sometimes when you just look at it one line at a time, you amazingly see stuff that you never would have thought. You find mistakes in capitalization or in indentation, you find logic errors, etc. You're effectively running the program by hand one step at a time. This becomes a little bit harder with J2EE, but at this level, this is fantastic and it's extremely helpful and well underused. Tabulating object state. An object's behavior is largely determined by its state. That's normal. So incorrect behavior is often the result of incorrect state. In other words, garbage in, garbage out. If the state isn't right, if the values that are used to calculate things aren't right, then the values or the fields that you use to store those outcomes probably won't be right. So sometimes it's as easy as look at the state of what it was right before the calculation, and you'll get an appreciation. Is it your formula or is it something before that? Document the state changes after each method call. This is when you're doing this manually, or it can be in a debugger. You should be able to predict what the values will be, and when you don't get what you predicted, you need to make sure that it is either your understanding that's incorrect or the code was incorrect. Verbal walkthroughs. Sometimes teaching somebody, you learn more than anything else. When you walk somebody through the code together, and you're walking through step by step what you're supposed to be doing, they will oftentimes see the mistake simply because you told them what it is, or you might actually see it as you're explaining to them because something clicks in the back of your head. It is an incredibly effective technique, and I strongly recommend you do it. The next one are print statements. In a small environment, these are okay. In a large environment, I highly recommend that you avoid them. There are other ways like log4j, which can approximate print statements, and that is a better way to go. Print statements can actually slow your system down and create locks inside the machine because of the way println works. It doesn't mean don't use them. Use them sparingly. Be careful because the output can be significant, as it says here, and you also want some ability to turn them on and off based on a debugging level. So if you haven't coded that into your system, consider implementing a static class or a static implementation in which you have a debugging level set. So this way when you run your system, it's done. And even better still, have that as some type of a global access method that's read from a file, so this way you can change it on the fly if need be. Print statements are very helpful, don't get me wrong, just when not used thoughtfully, you will have problems because it will cause performance problems or it will taint your screen or cause other issues. Choosing a test strategy. Be aware of the available strategies. Choose strategies appropriate to the point of development. If you're at the end of your development lifecycle, adding JUnit is too late as a rule. But if you do the stuff and you do it right as you're moving along, you will reduce TDM, human error, and makes retesting more likely because once it's in a harness, you simply, with a few clicks, test a bunch of code and see what you get out of it. Debuggers are language and environment specific. BlueJ has an integrated debugger. I've already covered it. It supports breakpoint, step, into, and step. It's very good. It's very helpful. You have a call sequence that you can see what's known as the stack, as well as the object state. Through these, you can usually find what the problem is. You can also debugging streams. It's a bit more advanced. There's different operations you can use in here. There's an example of the code down here. This is something I typically do not do, but it doesn't mean that it isn't worth exploring further. Just to review, errors are a fact of life. They're going to happen. No matter how good you are, you're going to end up with a defect at some point. It's natural. It happens. But you want to be the developer that has fewer than everyone else. So take your time. Make sure that you follow requirements. Make sure that you have a good design. Make sure that you have good JUnit harnesses set up. And make sure that all these things are done up front. Testing and debugging skills are essential. This way, when you get done and you hand in your code, if there is a problem, you can find it faster than anyone else. Make testing a habit. I can tell you now that developers who test and turn in the best code move up the fastest, and they're the ones that you want to keep the most because they do better than everyone else. Continually repeat your tests and practice a range of debugging skills. With that, that's the end of Chapter 9. Hopefully you got something useful out of this lecture. As always, please send me an email with any questions you may have, and I'll do my best to answer them as quickly as I can. Thank you.